Welcome to this video where we're going to run through the code you need to make a Markowitz bullet plot in Python. And we're going to do this using only daily returns and for as many assets as you'd like to include. Additionally, we're going to color each portfolio by the sharp ratio, and the plot will be fully interactive with hover text and zooming like you're seeing on the screen at the moment. Let's open up a Jupyter notebook and get started. So the first thing we need to do is import the packages that we're going to use. I tried to keep the package use to a minimum, and so for calculations we're only going to use pandas and numpy. Then for graphing we use plotly, which is going to give us really nice interactive graphs. And then the last package is tqdm, and it's just really useful for timing our code. So next let's import our data, which we have in CSV format. Looking at the first few rows, we can see that the data consists of daily prices for 6 stocks starting at the beginning of the year 2000. Then using the tail command, we can see that the data runs until midway through 2018. Now, since we're constructing an efficient frontier, which is essentially a line in mean-variance space, the first things we need to compute are the annualized mean returns and then the variance-covariance matrix as well. Thankfully, pandas makes this really easy for us, so we can use the .mean and the .cov methods, which will give us the mean and the covariance matrices respectively. Just one thing to note is that in the code here we've converted both the returns and covariances to annualized figures, and the 252 you see here in the code just simply corresponds to the average number of trading days in a year. So printing out the variance-covariance matrix, it has the variance of each individual stock along the diagonal, and then the covariance for each pair of stocks in the off diagonal. As a result, it's a symmetric matrix, which means that the upper right and the lower left parts are the mirror image of each other. And this is because the covariance function is symmetric. In other words, the covariance of x with y is the same as the covariance of y with x. There are really two ways to construct an efficient frontier. The more correct way is to find the exact solution using complicated optimization methods, but doing this requires using a lot of extra packages in Python, and it gets a lot more messy. So instead, what we're going to do is use a Monte Carlo approach, whereby we generate thousands of randomly weighted portfolios, and from them we can then discern the efficient frontier. Firstly, let's decide on how many assets we want in each portfolio. Any asset number less than 6 here is fine, since we have 6 assets in our dataset. Then we decide on the number of portfolios we want to generate in our Monte Carlo analysis. So let's just say 1,000 for now, to keep the plot from getting too cluttered. After initializing an empty list to store the expected return and variance for each portfolio, we can start on the loop to populate this list. So looping through for each portfolio we wish to generate, we first randomly choose the assets to be included, and then in a similar way we can randomly choose the weights for each of these assets, and it's really important to ensure that these weights sum to 1. So now that we've got our assets and weights for the randomly generated portfolio, we want to compute and store the expected return and variance for the portfolio itself. So we're going to use a couple of formulas here that I won't go into too much detail on, but if you want, I'll link an article in Medium that I wrote in the description, which touches on this a bit. At the end of this loop now, we have a list that contains 1000 return variance pairs, and each pair corresponds to the expected return and variance for one of the randomly generated portfolios. Now we can create a plot using the list we generated previously. When writing code for plotting, I generally do a lot of copy and pasting, both from previous projects and online samples, of which Plotly has many. I'll link the full code and data at the notebook in the description, and if you want to use it yourself, then you can very easily do that. So on the x-axis we have the annualized expected volatility of the portfolio, which is just the square root of the variance that we generated previously. And on the y-axis then we have the annualized expected return. Using these axes we can see a kind of a bullet shape forming, which is commonly known as the Markowitz bullet. However, this plot contains lots of suboptimal portfolios that don't actually lie on the efficient frontier. So to get the efficient frontier itself, we'll need to make some small adjustments to the code. I'll be making a similar video soon for producing the efficient frontier. It'll be based on the code you can see on the screen at the moment, which is actually already available at the link to my article or the GitHub in the description. If you found this video useful, please let me know by hitting the like button, leaving a comment, or subscribing. Right now, being as this is my first video, I'm actually sitting at 0 subscribers, so who knows, you might be the first.